All right, sorry about that. I was on mute. Thank you for attending this PowerCast, IBM Capacity Planning, Cloud, On-Prem, or Hybrid by Randy Watson and Alex Lazzaro, or Fortra. This PowerCast is sponsored by Fortra. My name is Ian Cartwright. I'm Education Manager for Common. If you experience any technical issues during the presentation, go and send me a message through chat. If you'd like to send a written question to the presenters, use a Q&A area, and they will answer your questions at the end of the presentation as time permits. As I said, presenting today are Randy Watson and Alex Lazzaro. Randy Watson, he's a 50-year IT veteran, spent the last 2 decades helping IBM business partners, and customers manage and analyze performance and capacity on the Power Systems platform on IBM I, AIX, iOS, and Linux. Also presenting is Alex Lazzaro. He's a professional services senior technical consultant at Fortra. He works on power tech and robot implementations for customers in Latin America, Europe, Africa, and Asia. All right, I successfully did the intro this time with the mic line open. So why don't you go ahead and take us away, Alex?
Okay, thanks, Ian. So, hello, everybody. Thanks for joining. And here's the agenda that we will be covering today. First, we're going to try to determine which of the servers that you need. Sometimes companies replace like for like, and that's usually a big mistake. We will try also to understand the licensing particularities on the IBM I and how they affect the decision that needs to be made. And then we will discuss how increased performance across the power generations allow you to consolidate workloads. And now, as part of capacity planning, we will talk about what is capacity planning, what do you need for analysis, the data that you will need to consider, what are your costs, and understand them, and we will give you a capacity plan example. But now we will have to go to a polling question because it's a good thing for us to know who you are. If you are a business partner, if you are an end user, if you are an IBM employee, also on which platform you are on and your releases. This will help you understand the audience that we have as an end user. Sometimes, well, as an end user, you have a full knowledge and understanding of your environment in terms of where you want it to go and which are your pain points. And you need to receive the most cost-efficient option, but you may not be familiar with the different alternatives on the servers and the licensing, the maintenance options, the additional costs, and all that. And you may also not have an OS SME or storage SME or virtualization SME, hardware SME, which are all specialists that you may need when doing a capacity plan. And the business partners sometimes struggle to understand the customer needs, and that's why it's good to have you here. So here we can see, okay, most are business partners. We have a third of end users. Okay, we have 44% on Power 8 and below, which is really interesting as Power 8 is being withdrawn in next year, March next year, and 56% on 7.3 and earlier. Okay, that's really good things to know. Okay, Randy. So can I close this one? Yeah, okay. So let me move ahead and we will see the different power processors that this is how the technology advanced. And with this advance, it makes you more able to do stuff with less cores. The CPU performance on the IBM I, in case you don't know it, is measured by CPW, which is commercial processing workload. The Power 8 delivered on average a bit more than 60%, a bit over 60% more CPWs than the Power 7. The Power 9 in turn delivered almost 40% more CPWs than the Power 8. And now the Power 10 delivers over 50% more CPWs than the Power 9. So for instance, since the Power 8 is being withdrawn next year, when you're moving for a Power 8, from a Power 8 to a Power 10, your processors will have, in average, over 100%, 110% more CPWs. And this increased capacity, along with virtualization, which is really important, is what allows the workload consolidation and the use of fewer cores. So what we will try to address on the first part of this session is the different options that you have and the different the particularities of each model. So first we have the scale out servers, which are the smaller, and between them the entry level systems. So the S1014, which comes on a rack or on a desktop version, it's a one-way server with 4, 6, or 8 core processors, up to 1 terabyte of memory. The smaller version has only 4 cores and 64 gigabytes. It has 5 I/O slots and 16 NVMe base. The S1022S, which is the smaller version of the S1022, is a two-way server. That means it has 2 physical processors with 4, 8, and 16 core processors, and it can go up to 2 terabytes of memory. The version that only has one single processor with one single socket populated with 4-core version is not supported on the IBM I. If you have the 2 sockets populated with 4-core processors, with a maximum of 8 core actives, it's natively supported. So you don't need to virtualize. If you use more than 8 processors, then you need to use BIOS. You need to virtualize. And you can have here 8 NVMe base, because this is a 4U server, this is a 2U server. So the NA's performance and scale, these are a bit bigger servers. The S1022 is 2-way, up to 40 cores. You can have 12, 16, and 20 cores per socket. It can go up to 4 terabytes of memory, and here you need BIOS. The thing that the benefit that you see here is that you can have more cores per U. Why? Because the S1024, which is this other one, is also 2-way. It has 12, 24, 32, or 48 cores. It can grow up to 8 terabytes of memory. It has 10 I/O slots and 16 NVMe base, but for you, you get only to have 48 cores. But if you use 2 of these, you get to have 80 cores, and they use the same space. This is 2U, this is 4U. So the important thing that happens with the Power 10 that didn't happen before is that this particular model, the S1024, changes the P group. And what's the P group? This is something that we will discuss later, but it's important value to determine the most convenient server for your needs. The E1050, it's not supported for the IBM I, so we're not spending time on this one. And the 1080, it's the really big one. You can have up to 240 cores with 10, 12, or 15 core processors. It has a 2U control unit, and then you can have up to 4 5U kegs. You can have a total of 64 terabytes of memory. You have 4 NVMe base per keg, but they are only for boot purposes. And you can have up to 4 expansion units per keg, which makes up to 192 I/O slots. You can also have up to 8 24 base NVMe expansion units for disk, which gives you 1.2 petabytes of storage. So what's the difference between what makes a difference between the enterprise and the scale out? Well, the reliability, the availability, and the serviceability. everything on the enterprise servers is redundant and allows concurrent maintenance on more components than the scale-out servers. And how about the cloud? Well, you're not buying a server here, right? But you still need a CPU and memory analysis that will help you determine the option that you will use. Normally, providers offer both scale-up and enterprise options. So you need to know from the provider the power models and the number of activated cores that they have. You need to know if they are on S922, S1022, E980. I mean, all the models we discussed before, you need to know that. And you need to know how many activated cores, because this will have an impact on your configuration and the licensing that you may need to get, not only for the IBM, but also for the third-party programs. The configuration that you will end up choosing will depend on the provider, because some of them charge by memory and CPU combos, some charge by CPU and memory separately, some change by CPWs and RPERF. There are lots of different factors, there are lots of different options, and you need to understand how they charge you. And we will discuss on the session about capacity planning about the PEP analysis and how it can help you if you're going to the cloud. You also need to understand the vendor's Power VM supported features and limitations, like entitled capacity, dynamic LPAR creation, like partition mobility, virtual storage pool. If they support or not those features, that will impact your decision. Now, if we go to the licensing particularities and we talk about the software licenses, here comes this P group thing that we discussed on the 1024, that P group changing. So what's the P group? IBM and most software vendors charge the software maintenance according to the P group of each server. And sometimes the P group is a mysterious value. And when you call IBM, it happened to me back when I was an admin. I was thinking about a system I will be receiving, and they told me to go to WorkClickInf, which was a bit complicated because I didn't have the server yet. And if you're planning to buy a new server, sometimes it's complicated to know which P group is the server that you need. The Power servers have different P groups. Today we have P05, P10, P20, and P30. And there used to be P40 and P50, but that's not anymore. Now, if we go back to models that we saw a couple of slides back, the one-way 4-core 64 gigabytes 1014, which was the smallest of them, it's a P10. The particularity of the S1022 that we saw is that you have a two-way server that goes from 8 cores to 40, and it's a P10. So that's really important. The S22S with 2 and 4 core sockets that you can have up to 8 processors can run natively, so you don't need a BIOS. And you don't have a core limitation per LPAR. But on the rest of the versions, you can only run LPARs that must be fully virtualized, and no single LPAR can use more than 4 cores. So it's a really good option if your LPARs don't go over 4 cores. But you need to consider that if right now you have an LPAR with 6 cores on a Power 8, well, the Power 10 is 110% more powerful. So you should consider this. The 1024, which we said changes the P group, the 12 and 24 core versions are P20, while the 32 and 48 core version are P30. And this didn't happen neither on the 824 nor with the S924. Like we said, the 1050 is not supported by the IBM, and the 1080 on all of its versions is a P30. So why is this important? Because, for instance, the OS is charged by core, and the cost of a core of a P20 is almost 3 times the cost of a core of a P10. Then you have also to buy a component that's called the access component for the P10, but if you have enough cores, it doesn't really make a difference. The access component is about 50K, so the licenses are for P10 around, without the discounts and anything, around 15K for a P10 and 44K for a P20. So you also have, and this is new, this is started with the smallest of the S914s, but now it is expanded to the rest of the servers. You have subscription licenses. So you can buy a 1, 2, 3, 4, or 5 year subscription. You need to understand at which point it makes more sense to just purchase the licenses. The licenses for the LPPs, some of them, like the LPPs, like BRMS, are licensed by server. I mean, you buy one BRMS license for the entire server, while other of the LPPs are licensed by users, which they can be named or they can be concurrent users. And again, for BRMS, for instance, the licensing on a P20 is 3 times more expensive than the licenses for BRMS on a P10. So again, the higher the P group, the higher the cost of entitlements and maintenance that you get. For instance, the cost of maintenance, and this, here's a link that if you receive the PDF later, you will be able to access. There are some products that the maintenance is included on the IBM, on the OS maintenance, with the P20 server maintenance being 30% more expensive than the P10 maintenance. And there are some products that have a separate maintenance cost. But again, these are also based on the P group. So that's really important. Now, regarding the licenses, you buy the licenses and you can transfer the licenses, but you can transfer them between P groups. I mean, they have two separated groups of P groups. You have the P20, the P30, and P50, and you can transfer the licenses between them, or you can have licenses from a P05 being transferred to a P10 or vice versa. You cannot transfer the license of a P20 to a P10, but sometimes, given that you will be end up using fewer cores, it makes perfect sense to just give away the licenses, do not transfer, because the licenses are transferable, but you need to pay a fee on them. Sometimes it makes sense to give away the licenses, buy new licenses for a P10 because it's less expensive. There's a particular license for application servers, which are servers that do not access a lot the database. That's a bit cheaper, but it cannot be transferred to a P10 or P05. That link will explain how you qualify for an application server licenses. Now, for the virtual serial number, you can buy a virtual serial number, and this came like a solution for the customers that could be in the cloud or could be on an environment where they use live partition mobility. You buy this virtual serial number, this number will stay with the LPAR. It doesn't matter to which frame is moved, but slide partition mobility is compatible only with frames under the same HMC. And the thing is that being a new serial number, you will have to get new licenses for LPPs and third-party software. So you will need to see how convenient it is to use this virtual serial number. Now, we spoke about how the capacity grow over the years, and we have an example here of a Power 8 and E880 with 40 that the end of support is on March 2024. And as we discussed, the performance increase is over 110 more CPWs on the Power 10 than on the Power 8. So here you have alternatives for the lower cost. So if you have a 48-core E880 that's capable of 491,000 CPWs, it's a P30 processor group, you can have even a bit more processing power on a 24-core S1024 that's capable of 585,000 CPWs, and it's a P20. And you can transfer the licenses. But if none of your LPARs here uses more than 100,000 CPW, that's roughly 10 Power 8 cores, which are 4 Power 10 cores, you can even go here. You can even go to a 20-core S1022, which is capable of even more CPWs, 638,000 CPWs. Though you need to reserve some capacity for the BIOS, but it's a P10. And the difference in costs is huge. So you can come and say, okay, I'm worried because this has a better reliability, serviceability, availability than this one, but I'm sure that you invest a fair amount of money on HA and DR solutions. You don't need to be afraid to use them. You have to have your people trained and ready for something to happen. Maybe it doesn't make sense to make a huge investment on an enterprise server when it's not your single point of failure. I mean, you can have a network outage and you still will need to use the DR solution, or you can have a natural disaster and your DC can catch fire. I don't know, but you will still need to be using that DR solution. So if you are using it anyways, why go to a highly expensive server when you can have this one? So that's something that you may need to consider. And in order for you to understand if your workload running on a server this big fits on a server like this, you will need capacity planning. And Randy here will explain us what capacity planning is, right, Randy?
Yeah, well, thanks, Zach. That was a great, brief description of all the things you have to think about, right? And obviously, to summarize, you need to think about obviously the hardware, capabilities, like how many cores, and if there's any restrictions, like the 922 has restrictions on it. But a lot of it has to ultimately do with the cost of the software. And he talked about a few of these things, like the P groups and third-party software and so forth. So when we, the analysts, are thinking about doing capacity planning, oftentimes we just worry about the performance side, but the financial side of this obviously ultimately is going to play a role in what direction we're going to go, right? So, if you just look up the definition, it's like, computer, and we're talking about the basic three components, right? CPU, core, memory, storage, and network, right? And you need to monitor and project the computer, the workload on this system, right? And for any changes in the configuration to satisfy, your demands, whatever those are, and I think the key word here is cost-effective manner, right? And so a lot of the choices that Alex was talking about obviously are going to affect best cost-effective manner, right? Now, how do you monitor this? That's a key word up there, right? Well, you need data, right? If there's no data, there's no analysis, right? So you have to have historical performance data is the key for a solid capacity plan. I mean, the more, the better. I can give you many examples of when customers do a capacity plan on like last month's performance data. So let's say you are a retailer and your big year is the holidays, like Black Friday, Christmas, that kind of thing, right? So, and you were looking at your machine in May. Well, that's not when your machine's the busiest, right? So you are going to potentially undersize the machine because you're looking at data that's not your busiest season. So ultimately what you're trying to figure out is your workload profile. In a perfect world, which rarely happens, you need a year's worth of data to figure out where your annual cycles are. A lot of businesses may not have cycles. Some of them do. They got month in, quarter in. You need to understand that stuff. And the only way to do that is to keep this history, right? Now, even though you have all this data, right, there has to be some methodology, right? How do I do this? And I'm talking about, do I do trending? Do I use a peak day? Do I use some kind of an average? Is it a time frame average and so forth? So there is some methodology here that you use on top of this data, right? So again, the two key things I just want to point out is obviously historical performance data is very important to do a quote solid or good capacity plan, right? And then methodology. So on the next slide there, it's what do you need, right? Obviously, what are the challenges, right? Well, like I said, is up front, Alex and myself, certainly we do this like almost not full time, but close. And it's the lack of historical hardware and or performance data. And it's just because people just don't think about it, right? It may be understandable, but it's one of these things, oh, dang, I wish I had that data. And of course, it's obviously too late at that point, right? So that's one thing, right? Just think about, if you're not doing it today, how are you going to do it? How are you going to keep this historical performance data? So that's a question, right? And the second challenge is many times people say, all I care about is production. So let's say a customer's got 4 LPARs. He's got a production, a Q&A, and a test, and let's say a file server, right? And they say, well, all they send us or the analyst is the production, because obviously that's what they care about. Well, when you're doing a capacity plan, even though you don't care about the performance of those other LPARs in theory, they do take up resources. So I like to say, when you are doing capacity plan, you're not doing capacity planning on an LPAR, you're doing it on a frame. You're not buying LPARs, you're buying frames, right? And you have many LPARs potentially on a frame. And in a perfect world, again, you would have all of those. Another example, and it's hard to get a hold of, is like flash copy partitions, because those things come and go, right? So if you don't have the data from all of the partitions, then you have to certainly allow for that. You have to understand that, hey, I don't have the full picture here. I only have half a picture. And again, what we're talking about here is how many cores you have, how much memory you have, because ultimately, as we talked about, a lot of this stuff is related to software dollars, not necessarily hardware dollars, right? And that's really what we're trying to do here. So, and then you have IBM's, again, getting into the financial world of it, they have these things called Processor Enterprise Power Enterprise Pools, PEP for short. And there's a version 1 and a version 2. Version 1's been around a long time. Version 2 has been around. First, it came out on the enterprise, and then it was announced that you can actually do this on 9 and Power 10s now on some of the scale out systems. This is IBM's way to have cloud-like pricing on-prem. So that's the best way that I know how to describe it. It's complicated. but it is the way IBM structures financially how you pay for software and cores and stuff like this, right? On-prem in a cloud-like manner, which basically is, if you think about it, and we'll talk about this a little bit more, is, pay as you go. Pay for what you use. Don't pay for what you are not using, right? And then, a lot of times, you need help in doing, this analysis. And part of that is, there's a third party could help you, like IBM could help you do this. A business partner could help you. Certainly companies like Fortra, we could help you do this, right? And it's because really you have to have a lot of disciplines. You need to understand the hardware. You need to understand the OS and all the features and how much it costs and what's chargeable and what's not chargeable. What are the financial options? So, like, for example, Alex mentions they came out with this new subscription model for the OS, right? So really, a lot of this is talking about CapEx versus OpEx, right? And that's obviously a financial term, capital expense versus operating expense, software and hardware. If you're looking at storage, and a lot of people think when they're talking about capacity planning, they only think about cores, which is understandable because that's where a lot of the money is. But, there's 4 components basically, right? And so there is a big component about storage. And then you have to look at virtualization. In other words, you got to be a Power VM schmeat, because there's a lot of things about Power VM that can help you control the cost of software, for example. For example, the best example is virtual shared pools. So there are mechanisms in the virtualization technology that can help you control the costs, right? And then there's cloud options, right? And as Alex mentioned, they're all over the place. And when you're going to the cloud, again, you're trying to size the machine. And in general, I'm going to say, when you buy a machine on-prem, the general thought is, I'm going to buy it and make this thing. I'm going to buy it big enough upfront that it lasts, 2, 3, 4, 5 years, whatever your buying cycle is, right? Or at least have the capability to, increase it as I go, right? When you go to the cloud, mostly it's sort of, I'm going to configure a machine to pay for only what I use. And obviously, one of the big reasons, a reason to go to the cloud, in theory, is to save some money because you're only paying for what you use, right? So, and again, this all depends on what cloud vendor you're looking at, because they all charge differently. But when doing a capacity plan, you certainly have to understand how they charge, as Alex mentions, what machine are they on, and so forth. So that's something to just think about. And that's sort of why a consultant or a third party or IBM or a business partner usually can help you understand that, because, when you get into financial, for example, you need business partners to run a config. How much does this thing cost? Well, that's going to take a business partner to do that, or an IBMer to help you understand that. So those are some of the challenges we think.
Yeah, Randy, and there's one thing. I mean, you not only need a specialist, but you also need the right tools. Doing the analysis for the PEP analysis, it's really complicated if you don't have the right tools, right?
Oh, absolutely. Yeah, it's complicated. Again, like I said, IBM can help you do this. They do this in, Expert Labs is one of the people you can go to help you do some of this stuff, but it is complicated. But, if you don't have the data, they can't help you anyway, or nobody can help you if you don't have the data, right? So that's, again, getting back to that, the more data, the better, right? So these are just some of the challenges when we're thinking about capacity planning. So, what do we need, right? So if it's IBM I, or obviously, it's collection services. That's the data that we're talking about when we say we need historical data. And for those who may not know, collection services by default is running 99% of the time, unless somebody turned it off by mistake. By default, there's only 10 days of data on the machine. And the reason for that is it can consume a lot of disk space. If you could, one of the issues with keeping a year's worth of data, right, is disk space. Not to mention, how am I going to analyze a year's worth of data, right? So, but by default, there's 10 days of data. Now, unfortunately, we do a fair amount of capacity plans with 10 days or 15 days or whatever. I mean, unfortunately, right? And that when we do that, there's certainly a lot of caveats that we go along with any capacity planning. It's sort of like say, hey, we have data in May and you are a toy company and your busy season is in August and September, because that's when you're doing all your picking and packing and shipping, and so you can get the stuff in the stores to sell, right? So there has to be some caveats with that, but that's where the data comes from. You can look at this data through Navigator for I, obviously. And the other thing remember we're talking about managing a frame. One of the questions we didn't ask, but the thing to think about is, this Power system can run 4 different operating systems, right? It can run IBM I, it can run AIX, it can run BIOS, and it can run Linux, right? So, again, we're not upgrading an LPAR, we're upgrading a frame. So if you have other operating systems, you need to be able to grab that data as well. So whatever method you're going to use, you need to look at, that. So AIX, by the way, typically it's going to be Topaz or Inmon. Topaz by default is running, and there's usually 7 days of data of Topaz data. Now, Inmon is a better source because it has more data, particularly in the disk in the memory area. But Topaz is fine if if you're on the CPU and core side. But again, depending on what you're looking at, that's what you're going to do. Now, for Linux, and there's open source that does that. So the best example is open source Inmon. Inmon is open source, written by the same IBM person that wrote Inmon for AIX, which is now developed in Austin or maintained by Austin. And then there are third-party solutions that you can use, right? So there are open source companies that do collect historical data. There, LPAR 2RRD, there is Zabbix, there is Nagios, there is, I'm going to say a handful of other third-party people that are meant to help you collect this historical data, right? So just things to think about, what do I need, right? How am I going to do this, right? So obviously, what data is it, and then what piece of software am I going to use to keep this historical data? That's kind of what you have to think about. So on the next slide, if you think about, well, I'm going to turn it back over to Alex to talk a little bit about, return on investment. What things you need to think about, when you're thinking about the financial side of capacity planning.
Yeah, and now that we discussed the server options and how the licensing is determined, the possibility of consolidating workloads and what the capacity plan is, you need to put all of this together, and you need to do a return on investment analysis. So you need to consider all of the costs. You need to consider the hardware costs. You need to consider the frame and the cards, the network, the storage, the sound storage, the disk options. I mean, you will have to weight the cost versus the desired performance, when you can use internal and when it makes more sense to use external, not only from a cost perspective, but also from a functional perspective. Then there are the switches, the latencies. The internal NVMEs are a really great option now for really fast disks. You need to consider the licensing, like we said, the P group of the system, the P group of the system that you have now, and the P group that you will end up having, and the cost of transferring a license versus the cost of getting a new license. Those are the OS costs. Basically, if you are using a P10, you will also need to consider the access costs, because those 50K that I mentioned before, that's for no max access. You can actually purchase licenses just for the users that will access the system. Then you need to consider the LPP, the license product programs, the third party costs for the software, like I don't know, for IBM, your monitoring software, your banking core application, for AIX, your Oracle or your SAP costs that they are charged by cores. Then you need to also consider the maintenance costs, the DR and HA costs, and then if you don't have a data center, you need to consider the colocation costs. So you need to understand how they charge you. If they charge you by rack space, the power, how it is charged, the network connectivity. And finally, if you decide to go to the cloud, you will need to understand how those costs are defined. How do they charge you? What do they cover? If they cover HA, how do they cover HA? What are the costs for the network? So that then you can compare to having on cloud versus on premises, or you can think about a hybrid solution. So you need to consider all of these costs. You need to put them on a nice spreadsheet and compare the different options that you have. It's not like there's one solution that fits all. No, you can have the right solution for you. So at this point, and I hope we didn't talk a lot just to make you confused. Do you know the difference between these two, the 1022 and the 1028? Does anybody, you can answer in the chat if you want. Which one would you choose? What are the difference? Why are they different? If you think that you may know, you can reply in the chat, or we can just talk with Brandy about this.
Well, the reason we bring this up, obviously, is he mentioned the 22 is a P10 and the 24 is a P20 or P30, right? So there's a lot of dollars involved. So for example, you may have a 924 or an 824. So you may think, oh, I got to go to a 1024. Well, maybe not, right? And again, this gets into finance. Now, of course, there are some limitations on the 1022s he talked about, right? So you have to think about those things, right? And you know, if you're going to the cloud, so a lot of cloud vendors are going to have the P1022, 922 because it's a P10. So a lot of your cloud vendors, in fact, just about every one of them, you know, their scale out systems are the 22, you know, 922, 1022 versions, because it's a P10 and it's less expensive and it takes up less rest space and it takes up less electricity and it takes less cooling and, you know, all of those things, right? So it's a very efficient machine for the amount of cores you get. So you have a lot of cores, as Alex mentioned, right? But you do have limitations, right? So that's some of the things just to think about. And again, there's a lot. And if you have like an 880 today, well, there's no reason you need a 1080. There may be, but you know, that's the things you have to think about. So again, this is just looking at it from a hardware perspective, much less all the other things you have to think about that on that previous slide.
Okay, so now I think that we have a capacity planning example, Randy. So I will let you go through that. Sure.
So we tried to find a good example that says, you know, once you get the data, you think of it as, you know, you have the data, you're doing the analysis, and now you're at a fork in the road. I could go down, you know, the 1024 road, or I could go down the 1014 road, or I could go down the 1024 tweet. So in this case, this particular customer could actually go down, pick any one of these three machines. Now, which machine they pick obviously not only has to do with financial considerations, right? but obviously whatever the future that they think is going to happen, right? So let's go look at and by the way, this customer had one 1024 with 6 IBM I licenses, and the other one with, which was a 914 with 2, right? So they had a total of 8 licenses, but again, there are transfer rules. So, and let's look at this. So one of the things, this is a little nice report that it's the hardware summary. So, looking for the executive. So you can see at the top, there was 2 frames and there were 2 systems. So there was only 1 LPAR per each system. A lot of time life gets more complicated because you have a lot more LPARs on a frame, but this is a simple case. Now this little summary page just totals up, all the CPW and the RPerf and how many cores. And so you can see between the 2 machines, there's 14 cores. However, you've only allocated 8 of them. And that's because, guess how many licenses you had? You had 6 on one and 2 on the other. So even though there was 14 cores, you only had a license for 8 across the 2 machines, right? And you had 8 virtuals, which, in this case, it's a 1-to-1 because, again, this is just a very simple case. They didn't even have VIOS on it. How much memory is in the total enterprise? How many disks are there? How many LUNs are there? And how full it is, right? And then how many versions of the operating system? So the other thing you have to think about, and obviously IBM and business partners can help customers understand this, is obviously, for example, you can't go to a Power 10 if you're running 7.1. You can go to a Power 9, but even then you have to have a special feature installed, which does cost money. That's a small amount of money, but you can technically do it. So the features and functions of what version of the operating system, and we're talking about IBM I here, right? So, it's not only the version like, 7.2, 7.3, 7.4, 7.5, but it's also the TR release, technology release. So in order to be at support for a Power 10, for example, you may have to be at, not necessarily the highest TR level, but certainly probably one back anyway. On an operating system. And you can see the 2 different models, right? This customer had a 41A and a 42A. So on the next slide, you can see a little bit more details about each frame, right? So again, there was only 1 LPAR on this thing. So you saw the 2 licenses in 1 license. So again, it's just a nice summary of the before picture, right? So this is, you need to understand where you're coming from in order to understand what the best options are going forward, right? So this is sort of just a nice picture and how it's allocated. And you can also see in that configuration, it's important to understand the virtualization of the machine. So in this case, they're in the shared pool, but they are capped. So like this machine, the first one has 8 cores and they're only using 6 because that's how many licenses they have, right? Now, you'll also notice that first machine has a second LPAR. See, it said there's 2 LPARs. Unfortunately, we didn't get that data. Now, in this case, I believe that LPAR was configured, but it was turned off. So that number, by the way, comes from the HMC. So in the performance data, collection services, it sort of knows how many LPARs are configured. Now, again, whether they're active or not is a different question. But see, the first question I ask as an analyst, well, where's the other LPAR? And in this case, they said, oh, it was an LPAR we just configured and never used, just turned off. So, but these are questions you need to sort of, ask yourself to make sure you have the full picture. Now you can see the bottom one was was in dedicated cap. Yep. So it's dedicated and it capped, right? So that's slightly different, which is okay. I mean, that is another way, again, to control your software costs, right? Is dedicating a machine, right? So you got 2 P10s and you got 6 P20s. So then we said, okay, what are we going to do? So the first thing we do is on the next page is this gets into the methodology. And I like to call this, we're going to consolidate these 2 machines on a single machine. That was the goal. And this is the 924. So this is their existing, if you ran this on the existing 924 8-core machine. So you could, because remember on that machine, you only had 6 IBM I licenses. So the one question is, if I'm doing a consolidation, how about I get rid of the 41A and just move that workload over and create a different LPAR on this machine? Would that work, right? So part of the methodology here is, you can see in the footnote here, it says it's a peak day, right? So I like to call this the perfect storm. So this is a methodology. This is the one we use most often because it is conservative, right? The last thing we want to do is go through a capacity plan and you upgrade and all of a sudden you're hitting the wall, right? So you do want to be conservative. So what we do is scan the data and figure out what day used the most CPU milliseconds. And of course, this is a 24-hour picture in this case, from midnight to midnight. And you can see there's 2 different days. One was March the 1st and one was April the 11th. So this is what I like to call the perfect storm. If the peak workload on these 2 were to run on this machine in a shared pool of 6. So because you have 8 cores, you don't want to look at it like that. You want it because it's how many licenses you are. So the other thing is down at the bottom, it says room for growth. So you can see that at like 1500, you peaked out at like 50% busy. So that's like a 92% room to grow, which means if you grew that point would be 100% busy. Most people don't understand what that's a new concept. So we convert that to what they're more familiar with, which is an annualized growth rate. In this case, it would be 24% a year for 3 years, right? But this is, that you could do that, right? You could just stay with that one machine, or you could go to the next what if, and you could say, hey, I could buy a 1024. Now it doesn't come in an 8-core machine. It has a 12-core machine, but you can see I could get basically the same performance that I got on a Power 9. See that peak is a little over 50% busy with 4 cores versus 6. So, and in this case, because they're both P20s, you could transfer these. So the question here is, technically speaking, from a performance standpoint, you probably don't need 6. You don't need to transfer them. Now, the transfer cost in the US is like $6,000. So, but it's also, you got to think about SWAMA, right, for the next 3 years. But so it's not, quote, a lot of money, but if you're if you're the admin person and you want this machine because you want the phone to quit ringing, you need to convince the financial people this is the best decision. You could say 4. Now, if they let you transfer 6, all the better, right? Because that even means you have more, more room to grow. But it's able to, look at this machine, from that point of view, right? So, but that's the second option, right? So the next option is you could actually go to you could run this with 3 cores. What if I want to transfer half the cores? So what we're doing here is we're tweaking the financing of this thing. This gets into where you have to understand, you don't necessarily have to be a financial SME, subject matter expert, but certainly you have to, and a lot of this you're going to get from your business partners anyway, the dollars and cents, but this is something you could do. And oftentimes we hear the term, all of us on the phone, I'm sure, people saying we're going to get off the IBM I platform, right? We've heard that more than once. 5 years later, they're still on the platform, right? But, their thought may be, I don't want to spend a lot of money on this. I want to spend enough money to last me the 2 or 3 years that it's going to take to get off of the platform, right? So these are the options to think about.
Sorry, and sometimes it's because they believe it's expensive, and that's not the case. If you choose the right model, it's not the case at all.
Yeah. So that's another option, right? So now we've had 3 options. So you could go to another option. I could actually go to a 1014. Now, like Alex said here, you could run it on it's a Power 10 processor. You can run it on 4 cores, just like you could run it on a 1024. The issue is here is you would have to throw away your P20 license and buy the 4 P10 licenses. So now it's a financial question, right? Does it make sense, right? And of course, maintenance is less and SWAMA is less, and it's not just the initial cost, right? You have to figure out the ongoing cost over X number of years, but you could do that, right? You could actually go to another option. So again, you can see both system names. So I'm consolidating both workloads, right? So on the next page, you can see it's a 10, I think it's a 1022, isn't it, Alex?
That's right. Yes. Sorry.
Yeah. So you could actually go to a 1022 because neither one of these LPARs needs 4 cores. So remember, that's a limit, right? On a 1022, any given LPAR can only have 4 cores. In fact, you can run both of them in a pool of 4. So you technically we just gone through using the same data. We just went through 5 options. So this gets into understanding, once you have the data and once you've gone through the analysis, there's a lot of paths potentially you can go through, right? And again, this is just saying, hey, this is what you have. This is what history is. Then you have to go on top of that. Well, what does the company think? Am I going to stay on the platform? Am I going to add AIX or Linux to this platform machine? Which, as I'm sure a lot of people, for example, most Linux VMs wind up on x86 because that's just sort of the way the industry thinks. But Linux does run better on Power. And SAP is a great example, right? Which, by the way, is a Linux operating system. So for those who may not know, so that, encouraging. So you may want to have more room on a machine just because you're thinking about, I have some other operating systems in my company that could benefit by running on this machine. So I think that's yep. If we want to go to one more, and
and that's all. And there's one thing about this one, the 1022, that you have 4 cores for the IBMI, but you can still have 16 cores or 36 cores left for another operating systems. And you went down from a P20 to a P10. So I see questions saying that the easy way to convince finance is to forward the complaint calls. Well, you can convince them by saying, now we are spending 1/3 on the licenses. Now our maintenance will be 30% lower. So when you start talking numbers, you start talking the same language that they speak. And actually, it worked for me when I was assistant administrator. The way that I found of getting new systems was to showing them how much they will not save, but how much they will lower the expenses. And I think that's the way to go with the finance guys. So now let's go to the final slide. That's for questions. So if anybody has a question, feel free to ask.
Great, thanks. I see that Randy has been answering questions in text form as we've been going along. There were a couple questions about the replay of this event, as well as a copy of the presentation. Yes, I will post that shortly. You can find it in the Common Learning Management System. It should be up within a couple of hours. And are there any other questions? Seeing none, why don't we go ahead and end here? Thank you, Alex. Thank you, Randy, for a great presentation.
all right. Well, I appreciate everybody's
thank you.
attendance, and you can always reach out to Ian that can get the presentation, or Alex and myself at Fortra if you have any questions, related to this topic.
All right. Good deal.
Thank-
Everybody have a
thank
good
you.
day.
Bye.
Thank you. Bye.